Victor Emmanuel from Bara University of Science and Technology, and I'm going to take you through a database project that I designed from scratch about a sales database. My area of interest was the supermarket database, and under supermarket database, we have items like a sales database, production database, a customer database, an inventory database, a supplier database. Technically, this field has a number of databases that are associated with it. But my area of interest was designing a sales database. Why did I choose it? Because I believe that with this area, with a sales database, we can design something that is not just for supermarkets, but can work for a number of retailers all around the 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 globe, the country like Uganda, or country like Uganda. And we chose this kind of database for cases like record keeping, where we keep records. And when you keep records, it helps you to scale and increase your database into a bigger and a better database. Yes, the business case. What exactly does this database do? That is what the business case. This database, as mentioned earlier, is primarily a sales database. So we are trying to keep records of what we have sold, and then we're keeping records of how much we have bought so that we can tally, see the profits we're making and things of the case. So for that case, we're going to have our database being primarily used by employees and entrepreneurs. So the employees definitely are the ones that put in the data directly into the system, into the database, but then the entrepreneurs could also have be the ones with the administrative rights to alter the different cases of how the database works and everything that is in the database. Also, this database, we shall definitely have customers using it because they will be also recording in the data that they are getting. For example, some loyal customers would have records where we can keep, and then we can see how many are getting items on credit, how many are actually pursuing them. We also get to see how many are paying through bank so that we can get to know which bank accounts. We can see how, like, we get to understand how the customer relationship. And then we also have the suppliers who also use this kind of database to store what type of products that they're bringing into the company, what type of products that they're going to pick out that they're bringing into the company, the expiry dates, and things of the sort. The advantage of this database over the ordinary bookkeeping, uh, first of all, it's more efficient. You know, when you have a database like this one, you will be putting in data and it will automatically be saved. You will reduce on the cases of you making mistakes when you do everything, when most of the things are automatic. Once put in, you just put in the product item code, and then you automatically get a number, you automatically get to know how much it is costing, and that is all put into the database. So that would count for efficiency and accuracy. As you're doing this, you're working faster and you're being more accurate. You're producing products on a better and some product, you're selling your products faster, and you're giving a better service to the people. And then with such a database, we can quickly scale. We can scale our products so they can be held out for a number. We can scale our business so that it can grow up to a number, to a greater number, without changing necessarily the database style. Do you remember if you are keeping your things in books and then you're recording them in in specific tables, then with those tables put in place, once your business probably scales up, you're now having more products, you're now giving more offers, it may be difficult to change the entire system and the way the architecture of the database originally and the architecture of the new database may be completely different. But with such an database design, we can have it very easy to flexibly change from one system to another as you're increasing in volume in your business. And then we have security because with such a database that is online, you can easily access it from anywhere. So that means in case it's burnt or something like that, remember books could be burnt. And then most cases, books do not have things like locks on them, passwords. So anybody could just easily get and access your data. But with such a database, your data is safe and secured in a specific place. So have you can restrict who can see it when and how much of what they can see. All right, so the limitations and costs. Obviously, with such a good system, there are some few things that are going to limit it. The system may not be 100% efficient because of some things like the fact that it depends highly on technology. So this database specifically is a web design database. So it requires someone to first of all have data to design to work on the database and then also have technology. That means a computer, you have a phone, you have something like that, which wasn't the case originally because one would just have a book and a pen and those were pretty affordable. So these things are a little bit expensive and they depend on technology. When there's no computer, when there's no electricity, when there is no, someone cannot work on their database. And then the system is now prone to cyber attacks. Before you were having a book and then you're only worrying about petty thieves or fire outbreaks. But now when you have your database and it's now out there, it could be attacked by different people. It could be hacked in by hackers, and then some of them can alter your data, change your data, and that would not be a good thing for your business. And also, there are heavy initial and maintenance costs in comparison to the original manual bookkeeping. You see, now you're going to invest in buying a computer, in buying data, in buying tables, in buying a lot of things, which was not the case. As I can continue, I can say, you see, you have, when you're buying this, you're going to have to buy a license for a proper management data system, which was not the case with the books. So it kind of puts a limitation on how you can utilize the data in comparison to the database in comparison to the original bookkeeping. Um, when we also see costs like software costs, just as I've said, like you have to buy a license for MySQL for this kind of data, for this kind of database, you have to get a licensed MySQL, which is a little bit more expensive than someone who buys just a book and a pen, a lot affordable. Um, the hardware costs, just as I said, you need a host computer, the one that's going to host. You need storage devices. You need networking equipment. You need data. You need a lot of things. You need a router. You need hardware costs, and then also there will be costs that involved in consulting professional guys because when you get this database and you're giving it to someone who doesn't know how to operate it, they will require a system administrator, they will require a software developer, and all these extra costs that could be a limitation. But though the costs are there, it is pretty worth it. It's pretty nice because the advantages definitely outweigh the disadvantages. All right, so to start up with the database design itself. So we're going to first take you through the logical design, and the logical design would consist of the entities. What entities are in the database? The database has customers, the customer entity, the product entity, the receipts entity, and the supplier entity. So what is an entity? An entity is like a table. What is that table that is in that database? So it is my this database specifically has four tables, and each of those tables is that is the kind of data that we fill in into our database. Uh, So this is small table summary that is going to show you the kind of database, the kind of entities, attributes that are in each entity. So as you can see, the customer entity has attributes like customer name, where you put in the name of the customer. So this could be the customers who have been accessing and buying products from your database. Then you have customer ID, which is the primary key specifically in this kind of table. And then we also need the customer's contacts, just in case you want to make a refund, you have promotions, you have some things that we're giving up. So we get to go to record the customer's contact. We also have the product, or we have the product name. So we write down each name of the different products that we are putting into, that we're selling in our supermarkets. And then each product has a product ID, or you could say a barcode that uniquely identifies each and every product. It's going to help us in this barcode. So when you put in this barcode, which is a primary key, someone can easily access and know, oh, this is a primary name, this is a the price of that product. Just like the same way when you put in the customer ID is associated with the customer name and then the context. So in the product table, we also have quantity, whereby since it's a sales database, we are mainly figuring out in how much this person is selling, how many products is this person bought. So that is why we have the quantity part in database, this database design. And then the last one is price, obviously the price of the commodity. Continuing, we also have receipts, and then we have the receipt, and each receipt has a receipt ID. So we can definitely trace back which receipts has the customer received, when was it issued out, all those things. So each receipt, we know how much was accounted for each receipt. Every receipt has a total amount, and then we also have date and time. So date and time for when was the receipt issued, how much is the receipt issued, and how much time. When was it and how much money did that receipt showcase. Then lastly, we also have the supplier. So with the supplier, we put in the supplier name. We have to get to know which suppliers are working with us, which suppliers are giving us products. So, and what products are they giving us? So having the supplier name, then the supplier product, and then the product ID, which could be the same case. So it could be a foreign key. Supplier ID is something that will link us to the product because it's the same. And then how much has the supplier given us, plus what day and time did the supplier give us. So these are the relations that relates the different tables that I have just explained to you earlier in the previous slide. We have customer. So a customer buys a product. It's a relation. It's a relation between the customer and the products. The customer buys a product. A customer is given a receipt. A supplier gives a product. So it's kind of something that relates to from a customer to a product. A customer, how we are relating the different tables in our database. As you can see closely, if you look closely, you can see that I've added multiplicities on each of these relations. So a customer and product have a one-to-one, a one-to-many multiplicity, showing that one customer could buy one product or one customer could buy many products. So that's why we have a one-to-one multiplicity. Or we could have that one product could be bought by one customer, or a product could be bought by many customers. Like how you can go and then one person buys one bottle of soda, or one bottle of soda could be bought by different people, each buying one bottle of soda. Or and the reverse is also true. So we have the same understanding for the multiplicity of the customer and the receipts, where we say that one customer is given one receipt, and yeah, customer and receipt, each customer is given one receipt. We do not expect a customer to be given more receipts. So for every purchase, they receive a single receipt, and that receipt is also given to one customer. A receipt is not given to many customers. Each receipt is accountable to only one customer. That is why the multiplicity is 1 to 1. Then lastly, the multiplicity of supplier to a product is one to many, just like for customer and product, where one supplier could give us one product. So we could have, for example, a supplier that is only providing torches. And so that one supplier is only providing torches. Or alternatively, we could have a supplier providing so many things. It could be when it's providing bananas, you're providing cups, it's providing butter. So that one supplier is providing so many things. The same thing, the product could be supplied by many people. It could be soda, and then we're having soda being supplied by Fanta, I mean by Coca-Cola products. We could also have soda being supplied by Pepsi suppliers. So that we have a multiplicity of one to many for such a relationship. As you can see up, this is a detailed ERR model for the entire database, just as I've explained. So we're having here a detailed ERR model with each each entity and its attributes, and just showing you how they're all related. Yes. Okay, so having looked at the logical design, we're now going to go ahead and take a deeper look of how does a physical design look like? How does it work? How does it actually function? You get? So as I explained earlier, that it's a web-based database. So generally, it will be running on a website. That gives us the advantage of designing the CSS in different formats according to what the customer what the person receiving the database likes. So the CSS can be altered into so many different designs. That is why I took on for web-based database, because it's simpler to design and simpler to change work around the CSS. What you see here above here is just an example of a form, a receipt form of how it could look like, because well, as a customer, you leave, and the employee will put in the product ID, which could be the barcode, and then how much of that product have you bought, what amount have you paid, and then what's the balance, and then we generated a receipts, and this can run up for so many different products, so many different things. So all you have to do is just keep on putting in the different product IDs, and then you associate them with the different quantities, then you just mention how much and then the balance. So here, a person running a very large business can get to know to the least cent of how much money was given to this employee at this employee's desk, and then how much money do they have currently, and then there's thing. All right, my battery is running low. I'm about to finish. The physical design I also have. With the physical design, I have here an example of MySQL, the different prompts that I used when I was designing. As you can see here, we created the database of the supermarket, and then after creating it, then we called it where we used it, and then we created a table, and the different table, just as you can see clearly there. Yeah, this is a different description of the different tables that I've just been explaining to you earlier. This is just my SQL, how it would look like in my SQL server. Um, yeah, I think you can pretty see clearly everything, the primary keys and everything. And then the last one here at the bottom is just how we're putting in the different values, just an example of putting in the different values that we're fitting into the database using MySQL, so that we could run a sample query just like that one. So this is a sample query, a query showing the customer ID, the numbers, the receipts, the different amount that was given, when were those receipts issued, things like so. Yeah, in conclusion, that is my project. I used a database system practical approach on those books above. I used a database system book, and I also used database management system These books came in very handy when I was designing the database, and they give me a detailed design.